Hi, I'm RJ, the Director of Perception at Zoox. Have you ever wondered how self-driving vehicles see and understand what is going on around them? That's what I'd like to share with you today. Just like human drivers, autonomous vehicles need to perceive their surroundings in order to navigate through the world. While you primarily rely on your eyes, Zoox robotaxis use a state-of-the-art combination of sensors strategically situated all around our vehicles. Each sensor type is complementary, and this combination provides our vehicles with the most accurate information about what is unfolding around them. Let's dive into how they work. Let's start with our cameras. They are unique in their ability to detect attributes like the color of traffic lights and even the facial expressions of pedestrians. But cameras are susceptible to severe weather conditions like heavy rain and snowstorms. They also cannot measure depth directly, and when things get really dark, it's harder to separate signal from noise. This is why relying solely on cameras for autonomous driving isn't the safest or most reliable approach. Next, we have LiDAR. LiDAR creates a 3D model of the surroundings. It fires millions of laser signals per second that reflect off objects and return to the sensor. LiDAR is great at detecting depth and measuring the shape and size of objects, no matter what they are, even if those objects have not been seen before. We also use radar. Radar works by bouncing radio waves off surfaces to determine the distance, size, speed, and direction of objects around the vehicle. Radar has three advantages. It provides velocity measurements with low latency, it detects agents at far distances, and it's robust in extreme weather conditions like rain, fog, and snow. Next, we have long-wave infrared sensors to detect objects based on their temperature. That enables our vehicles to more reliably detect objects that emit heat, such as people, vehicles, and animals, especially in low visibility conditions like at night. Finally, we have microphones that act as the ears of our vehicles. They are really valuable for detecting emergency vehicles, including where those vehicles are coming from. So as you can see, not all sensors are created equal. That's why we use sensor fusion to combine all the data. We accomplish this through a combination of state-of-the-art machine learning algorithms. These algorithms are trained and validated on both real-world and simulated driving models. We have a test fleet of Toyota Highlanders that are currently driving autonomously in dense urban areas like San Francisco, Las Vegas, and Seattle. If you are in one of these cities, I hope you see one. We've built our vehicles from the ground up, and this gives us many advantages. Our sensor architecture consists of 4 identical sensor pods positioned high up on each of the 4 corners of the vehicle. Like everything on the Zoox robotaxi, this sensor positioning is deliberate. It provides the vehicle with a 360-degree view of its surroundings, and because there's one on each corner, we have overlapping, redundant fields of view that enable the vehicle to see around things. That's what eliminates blind spots, and it allows our vehicle to view objects not just next to and behind it, but even objects behind other objects, which is especially important when navigating through busy streets. Our unique sensor configuration also ensures a fail operational architecture. What that means is that our vehicles can finish the ride even in the unlikely event that an individual sensor were to fail. And did you know that our robotaxis are bidirectional? Unlike a regular vehicle, they don't have to turn around to drive in the opposite direction. We have developed our perception system to make our algorithms direction agnostic, meaning that the models we train can work on any sensor pod in any direction. Another really cool aspect of building a vehicle from the ground up is that we have full control of our entire AI system. All of the sensors, time synchronization, monitoring system, algorithms, and everything else. That is a huge benefit, as opposed to having to fit sensors on a vehicle that was originally designed for you to drive. Our perception stack enables our vehicles to detect, classify, understand, and navigate many intricate and complicated scenarios in real time. Here's an example. Pedestrian behavior. We detect and classify that these people are sitting down on the side of the road. We also detect when a person is gesturing at our vehicle or if someone appears distracted by their phones. We can also predict when a pedestrian intends to cross into our path, classifying and safely reacting to these often subtle behaviors is critical for safe, autonomous driving. Another example, other vehicles. We've learned to detect if their brake, hazard, or reverse lights are on so that we can pause to let them park. We also sense open car doors around us and take caution that someone might be about to enter or exit the vehicle. Construction zones are another challenging scenario. Not only is our perception system able to detect and classify construction zones in real time, but we also understand if a construction worker wants us to stop and wait before proceeding again. Our vehicles are robust to a variety of weather conditions. Although rain and fog, as well as steam from manholes, can get picked up by LiDAR sensors as possible objects, our overall system is robust to these potential false positives because all of our sensors essentially get to vote together. So, what's left to be done? We're constantly advancing our autonomous capabilities, but there's still a lot of room for new algorithms and innovations. For example, one of the biggest challenges in self-driving perception technology is dealing with the long tail of edge cases and having the confidence that our vehicle will react to any scenario that it encounters. Zoox has adopted a sophisticated and comprehensive verification and validation strategy, spanning real-world dense urban testing, probabilistic testing and simulation, structured testing, and more. This validation strategy provides us a solid foundation for our commercial robotaxi deployment. I'm RJ. See you next time.